Hi guys, welcome back to the channel. Hope you all are doing good. So in this video, we shall discuss a quite difficult problem. It will take some time to explain and understand, but it is not as difficult as it appears once you get the correct approach. So let us read the problem carefully. Sum of minimum and maximum elements of all subarrays of size k. So all subarrays of size k, somewhere sliding window concept, something like that will be taking place. And we have to also find minimum, maximum, and the sum. So given an array of positive and negative integers, so positive and negative integers, we have to find we have to find sum of minimum of maximum and minimum elements of all subarrays of size k. So let us take an example and do this. But before that, see, this problem comes under stacks and queues. While you're doing the problems from this list, you can get an idea that you should use something either stack, queue, or deque. So if you observe carefully, can we use deque over here? And why can we use deque? So before I tell my explanation, I would like you to pause the video and think about it. So the hint is we can use deque. So as you might have understood by now that we can use deque to solve the problem. But before we start with the algorithm, let us just, uh, let us just take an example. So let us say the array given to us is uh, 2, 5, minus 1, 7, 2, 5, minus 1, 7, and minus 3, minus 1, minus 2. Minus 3, minus 1, minus 2. So this is the array. So the array has 7 elements, and let us suppose k is equal to 4. So the size of the array is 7 and k is equal to 4, and this is the array. So this is our array. Okay. Now we should first of all see what does it mean by subarrays of size k. So the size is 4. So we can have this subarray. This is having size 4. So let us write all subarrays with size 4. So all subarrays with size 4 will be 2, 5, minus 1, 7. Next it is going to be, see, this was one subarray. So this is like a window. This is like a window. Now we shift the window by one element. So this becomes the window. So this element 2 is now not a part of the next window. It has been eliminated. So we are sliding the window. So now our subarray will be 5, minus 1, 7, and minus 3. Now this was the window, and we will slide the window by one element. See, I am telling from basics because I can't assume everybody knows sliding window. So minus 1, 7, minus 3, minus 1. Okay. And the last subarray of size k will be, just keep shifting from one window to another, keep excluding the first element of each window. That's all. So now it is going to be what? Obviously, it is going to be 7, minus 3, minus 1, minus 2. Okay. Over here, what is the minimum element in this window? This is the first window. What is minimum element? Minimum element is minus 1. Maximum element, so let me write, minimum element is equal to minus 1. Maximum element is equal to 7. Okay. Similarly, in this window, what is minimum element? Minimum element is going to be, I guess, minus 3, right? We'll anyway verify later. Maximum is 7. In this window, again, it is going to be minus 3. So I won't write the others. I think you have understood now what is the approach. No, you have not understood the approach. You have understood what is the question asking, that's all. So this is the question, okay? We have to find minimum maximum of all the subarrays of size k and add this. We should add all these. And we have to return that answer, that sum. So why I was discussing about sliding window concept is, see, in the sliding window concept, we are shifting window by one. What does it mean? We are removing the first element of a current window and then going to the next window. That means, for example, consider this only. So this is first window of size 4. Now the next window of size 4, I don't know what is happening to this. Next window of size 4 is this. So you can see here we have left this element. This element was first element of the previous window. How can we use deque, and why should we get a thought that we can use deque? See, we need to do two things. First thing is maintain a window of size k. That is first. Second thing is calculate minimum maximum in each window. So we will use two deques. Double-ended queue. Deque means double-ended queue. So we will use two, one for minimum, one for maximum. What are the operations that the deque has to perform? It should first of all remove the elements which are not part of current window. How to do that in deque? We have a function called pop front. So for example, if we are in this window and we want to go to this window, that means in this window now we have to do pop front operation. So if we do pop front, this element 2 will be removed and we will insert new element and it will become this window. So that is why I need to remove from front and add from back. That is why I require double-ended queue. That is the reason. So I hope you understood why we are using double-ended queue. But obviously you have not understood how we are calculating minimum maximum. You have just understood when we should delete element, that when we should remove element. When should we remove? We should remove when we are going to next window. That's all. Okay. Now how do we find out minimum element, maximum element? So we will do one thing. Before we insert an element into the deque, we will first ask why should we insert element. It is better we insert index values, because ultimately we can find out the minimum maximum even if we know the index values. So we will insert index values into the deque. We don't have to insert the elements. How are we going to check for minimum maximum? So for that, let us see the code. See, I have coded it already and I'll show you. I have taken two queues, maximum, deque max, deque min, okay? And I've taken a sum variable. I am running a for loop and traversing the entire vector. I have already declared a vector over here in the main function and I'm just passing to the solve function with a value k equal to 4. So over here 4 is k. So this is solve function. And when I'm traversing these two if statements, are for what? These two if statements is for that window checking condition. This is like the window checking condition, because I have to delete the first element of a current window to go to the next window. Yeah, I have to slide it right from left to right. So that is performed in these two conditions. And why are there two deques? Because I have to calculate minimum as well as maximum. Okay. So if the queue is not empty and index of the front element, see, we are only storing index in the queue. If index of the front element is equal to I minus k, Why I minus k? Because I minus k will signify that I have now shifted the window. I am going to shift the window now. If I is less than k, then I am still in the first window. When I will become k, that means I have shifted to the next window, which I have explained in the previous example over here. I have explained in the example, right? So over here, if I'm considering this window and I'm considering this window, then I have to shift, I have to change this, I have to remove this element. So that condition is performed in these two statements. Now, how to check minimum maximum? So to check minimum maximum, I am writing this, I am writing these two, and I am inserting the index values in the deque. But what is this condition doing? What is this actually doing? Let us see. Let us understand with an example. So I have declared two deques, right? Deque min, deque max. So let us traverse and let us check. Let us take this example only. Let us take this example. Let us start now. 2. I have got 2. And now according to my code, what is it? So is deque max empty? Deque max is empty. Initially deque max is empty. So this condition can't be executed. Is deque minimum empty? Yes, it is. So this also can't be executed. While deque max not empty, it is empty. So this while loop can't be executed. Similarly, this also can't be executed. So I just have to push the index in both max, deque min. So initially index 0 will be pushed. Okay. So this element is traversed. Now we'll go to this element. Fine. When we go to element number 5, there what we should do? Now we will check, is deque max empty? No, it is not. Is deque max dot front equal to I minus k? No, I is equal to 1, k is equal to 4. 1 minus 4 is minus 3. But deque max dot front is what? What is front element of deque max? It is 0. So that if condition is also false. Similarly, for deque min also it will be false. But now what will happen to the while loop? See here, while loop, while deque max is not empty. Yes, it is not empty because it has one element. Now I am checking if v of I is greater than v of deque max dot back. So what is last element in deque max? Last element in deque max is nothing but 0. And what is v of 0 now? What is v of 0? See, this element is there. Now what is v of 0? V of 0 is 2. What is v of I? I is at first index. So this is v of I, 5. 5 is greater than 2. So we will remove this index. We will remove this index and we will just remove the index for now. Because we found out a greater element, we will remove that index. Now deque max is empty. So we will break out from this while loop. Similarly with deque minimum. Deque min is v of I less than v of deque min dot back. V of I is 5. Deque min dot back is 0. See over here, deque min dot back is 0. What is v of 0? 2. Is 2 greater than 5? No. So we won't do anything. So the situation now is like this. Deque max has become empty. Deque min has index 0 in it. But we should not forget this. We are pushing the index. So let us push the index now. So we'll push 1 over here. So we have to push 1 here and we have to push 1 here. Just a second. Okay, so this is the situation now. Now let us go to the second index. Is dq max empty? No. Is dq max equal to I minus k? No, because I is still 2 and k is minus 4. Sorry, k is 4. So 2 minus 4 is equal to minus 2. But dq max front is what? dq max front is equal to 1. So don't forget that this is for just the window condition. We are just checking if the element is outside the window or not. It is not outside. The window is not yet achieved. I mean, window is still to be complete, right? Now we'll check this while loop. Is dq max empty? No. Is this condition true? What is v of I? Now I is at which index? It is at index 2. V of I is minus 1. Is minus 1 greater than v of dq max dot back? Is it greater? No, it is not. What is dq max dot back? It is 1. What is v of 1? V of 1 is 5. 5 is not greater. So this condition is false. So this while loop won't execute only. What about this condition? Minus 1 is less than 5. See, v of dq min dot back. What is dq min dot back? What is dq min now? dq min has these two elements. So dq min dot back means last element. Last element now is 1. What is v of 1? 5. Minus 1 is less than 5? Yes. So pop this element. So this element is removed now. This element is removed. But the loop will still run. Loop will still run because the conditions are true. See, dq min is not yet empty and minus 1 is less than v of 0. V of 0. Why 0? See, 0 over here. dq min dot back is 0 and v of 0 is 2. See, v of 0 is 2. First element is 2. Minus 1 is less than 2. So remove this element. Now the condition is false because q is empty. So push back this index in both the dqs. Why are we pushing in both dqs? Because there is a possibility that answer can change in the later window. So push it back here and push back here also. Now let us similarly check for third element. Third element is 7. So these two conditions are not yet possible. Let us check this. dq max is not empty and 7 is greater than minus 1, of course. So pop this. So over here this will be popped. Now dq dot back, dq max dot back is, sorry, dq max dot back is 1 and v of 1 is 5. 5 is less than 7. So again remove this element. So now this became empty. So check dq minimum now. Is minus 1, is 7 less than minus 1? No, so don't do anything. And again push this element back here. Push this element. Now it will come to a printing part because see, now we have reached the end of the window. So this window is done now. Now we are going to this window. So we have to remove this element. How are we removing the element in the code? See, dq max is not empty and dq max dot front, is it equal to I minus k? So let us check that. So in this case, dq max dot front is not equal to 3. So actually what it means that this element 2 has already been removed, so we don't have to worry. But if this element 2 was there and it would be the front element, that time it would be removed. Okay. So like this the algorithm is going. And if I is greater than or equal to k minus 1, we are going to do summation, because we have finally got a window of size k. So where will we start doing summation? When did we start doing summation? So we started doing summation when I became k minus 1. See, at this index, this is index number 3. 3 is equal to 4 minus 1. So at that time, we started checking minimum maximum. Then we will do the summation. So I hope you have understood what is the use of deque, and what is the use of deque for, in this problem. We need to remove the elements as we keep changing the window if it is required. If it is required, and we need to check for maximum, minimum. And how are we doing? We are doing it at each and every iteration itself. We are checking with the inserted element, that is element inserted at the back of the deque. With that element only we are checking, because this will make our algorithm faster. It will make it more efficient. We don't have to check the entire deque and make it a O of n into k solution. We are checking before inserting only. We are checking before inserting itself. And we are inserting afterwards also, because in the future it might be wrong. We have to remove that time. So that was the code. You can look at it, and ultimately I'm printing the sum. So that's all for this video. I hope you understood something at least. Please like it if you did. Share it with all your friends as much as possible. Subscribe to the channel. It will really motivate me. Stay safe, keep learning, keep growing. Stay tuned. Bye.